let's see. How much did she miss it? The audience seems by a lot. 20, 21, 22, 23, 24.
Welcome to another episode of Math and Silly Hats. Today we'll be reflecting figures across axes or mirror lines. So I want to go over how to do this conceptually before I show you how to do it in ALEKS. We'll have digital tools to help us in ALEKS, but conceptually what we're going to be doing is looking at a figure, such as this triangle ABC, and we're going to be reflecting it across a line that operates as a mirror. Now, intuitively, we're going to call this the mirror line. It could be an equation, it could be an axis, it could be even a non-horizontal or vertical line. But what's going to happen is just like when you look in a mirror, ABC is going to look in its mirror, and its image, what it sees in the mirror, is going to be reflected, so opposite, just as far away from the mirror. You'll notice that the point B was 1 unit away from this mirror, so B prime will also be 1 unit away from this mirror. A was 2 units away from this mirror, so its image, what it sees in the mirror, is going to be 2 units away from that mirror. Let's go into ALEKS and try this. So in ALEKS, we're given some tools to accomplish this task. We can see here we have a horizontal and a vertical line that allow us to reflect things digitally. So if we're asked to reflect across the x-axis, our line of reflection is going to be the horizontal x-axis. And then we're going to have to give the coordinates of the marked point in the original figure and the final figure. So you notice there's a point down here. It's going to have a reflection somewhere up here because we're reflecting across the horizontal axis. We're going to have to first reflect this image and then give the location of both this point and its image. Let's start with the reflection. We're reflecting across the x-axis, so we're going to come up here to our reflection tool and we're going to choose the x-axis for our reflection line. You'll notice ALEKS automatically places our reflected object, and it is 2 units from this line of reflection, 2 units from this line of reflection to this nearest edge. So now all we have to do is name the coordinates of these 2 points. We name points in XY order, so if we look at our first point, it's 1, 2, 3, 4, 5 to the left, so -5 is its x coordinate, and 1, 2, 3, 4, 5, 6 units down, so -6 is its y coordinate. Let's put that in. The original point was -5, -6. Now we come back up to our figure and we find our post image, our new point. It's 1, 2, 3, 4, 5 units to the left, and 1, 2, 3, 4, 5, 6 units up. So -5, 6. Put that into ALEKS. -5, 6. Now you notice our y values here are inverses of one another. So we have a -6 and a +6, where our x values are the same. This may seem counterintuitive, but because we're reflecting across the x-axis, the x value is not actually going to change because we're just moving it effectively up on the xy plane. So the y values are opposite of each other because we reflected it across the x value. So it's just going to move from the negative to the positive in y space. Let's do one more. In this problem, we're going to be reflecting across the y-axis. Again, we're going to have to give the coordinates of the point both before and after our reflection. We're going to choose our vertical line, and we're going to choose it to be on the y-axis. ALEKS will automatically reflect our figure, so we now just have to record the points of our pre and post image before and after the reflection. So our pre-image was 1, 2, 3, 4 units units to the x value and negative 5 units for the y value. So we'll enter for our pre-image 4, negative 5. For our post-image, we're in the negative on the x value, same number though, 4, and negative on our y value. So negative 4 on the x and negative 5 on the y. Negative 4, negative 5. Again, you'll notice here the y values are the same and the x values are inverses of each other, because when we reflect across a vertical line, we're not going to change the distance from the x-axis. In other words, the y-coordinate is still just as much down as it was before, but we're going to move it from the right in the positive x direction to the left in the negative x direction. So our x value went from positive to negative, and our y remains the same. Hopefully you found this helpful, and now you can complete these problems on your own in ALEKS. Have a great day, everybody. Bye-bye!